one?
So we can do one in each section. So we could do 1, 3, 5a,
Okay,
6a.
here's what I'm thinking it says. F of x is x, and g of x is square root of x minus 1. Is that correct?
Yes.
What's to the left of the equal sign on the second row?
F of x equals square root of x plus 1.
And g of x is
Square root of x minus 1.
Minus 1. Now what I'm confused about is why do I have two g of x's and two f of x's?
Because they're different problems, I apologize. It's 1 and 2.
Okay, so the first one is 1, right?
Correct. The first row is 1.
This one is 1, and this one is 2.
Yes.
Okay, so find just domains and ranges. Okay. The thing to know here, well, you don't even have that problem on here, the fog. Okay, let's talk about domain. What's the domain of f of x and 1?
F of x and 1. So, could I put that on a calculator?
No. If I were to graph it, this is what it would look like.
It would just be 1 or a slash.
What's the domain? What domain means the allowable values for x. And then here, let me label the vertical axis as f of x instead of y. If you look at that graph, what are the allowable values for x?
Negative infinity to infinity, all real numbers.
All real numbers, exactly. In other words, there are no restrictions when the function is y equal x. What's the range of that function?
All real numbers as well.
Correct. Okay, now the second one, the g of x, is actually a little easier to figure out by looking at it algebraically. Okay, what is the restriction on g of x and 1? You're taking the radical, when you're taking the square root of something, what has to be true?
When you're taking the square root,
yeah. Can you take the square root of a negative number?
No, you can't. It has to be a positive.
Well, it doesn't have to necessarily be positive. It has to be positive or 0.
Okay. Or neutral. Yeah, so positive or neutral.
What we're going to do, we're going to take that function, and we're going to take whatever's inside the square root, x minus 1, we're going to make it greater than or equal to 0. And that's how you solve all of these kind of problems, where you have a radical sign. Just whatever is in the inside, make greater than or equal to 0. Unless it's a denominator, in other words, you can solve this pretty easily. X has to be greater than or equal to 1, so that's the domain for g of x and 1. There is one exception where if you had something like 1 over the square root of x minus 1, then what's the domain of that function? What is true of x minus
1? So if I graphed it, it would be going down 1, I believe.
You graph it. Just tell me, in other words, think about radical square roots of. What can you take square roots of, and what can't you take square roots of?
So that means the x value would either have to be 1 or greater.
Set it up as an inequality. Rather than trying to figure out what x value is, take whatever's inside the radical and make an inequality. Now the question on this one is that has to be greater than 0 or greater than or equal to 0?
Greater than or equal to.
No, because if it's equal, we'd be dividing by 0. In other words, most of the time, you can take the square root of 0. That's not restricted.
Okay.
Within the denominator, that you cannot divide by 0. So those are the two main restrictions you have with function. Is you can't divide by 0, that's the main one, and you can't take the square roots of numbers that are negative. So between the two of those, we get that, which means x has to be greater than 1, not greater than or equal to. And that's for the problem I made up, not for yours. Okay? So we've done that one, we've done that one. How about 2? Give me an inequality for 2.
So x plus 1 can be greater than or equal to 0.
Correct, solve that.
So then, hold on. So it'd be 1 over x plus, or square root of x plus 1?
No. Solve this inequality. This inequality.
Oh.
X plus 1 is greater than
So
or
subtract
equal to
1.
How do I solve that?
So would I bring the 1 on the other side with the 0?
Okay. What's that mean?
So that means x is greater than or equal to negative 1.
That's your domain. Okay? For g of x, we'll get back to the range in a second. But for g of x, what's the domain? What's my inequality? X minus 1 is what?
Greater than 0?
Greater than or equal to 0. So always greater than or equal to 0 when you're dealing with a radical sign, unless it happens to be in a denominator, and then it can't be equal to 0. You can take the square root of 0, but you cannot divide by 0.
Okay.
So this one is greater than or equal to positive 1. Now let's go back and look at range. Usually range is harder. But in this case, range is actually easier for both of these. What's the range of f of x have to be?
So then if I'm looking for y, would I have to make 0 for all the x's?
Now, just think about it for a minute. When you take the square root of a number, do you get a positive or a negative answer?
You get a positive.
Yeah, always?
It depends on the number.
No, it doesn't. Yes, the answer is always.
Okay.
Unless it's 0. So y, or f of x, has to be greater than or equal to 0. Just because it has to be. In other words, no matter what I put in there, I'm putting in things that are greater than or equal to 0, so y is always going to be greater than or equal to 0. If I graph the normal square root function, it looks kind of like that. In other words, that's y equals square root of x. Okay?
Okay.
And you can see what the range is from the graph. It's greater than or equal to 0. That heads to infinity in both directions.
Okay.
Okay? So the secret on range for radicals is square root of that has to be positive. If I were to take and add plus 2 to that, right there, that always has to be greater than or equal to 2, right?
Yes.
Yeah, because this part here cannot be negative. That's always going to be greater than or equal to 0, which means the whole thing would have to always be greater than or equal to 2. And so what's the range on g of x?
Y would be, so if it's a negative 1.
Not the domain. We figured out the domain already. The domain was x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1. That's the domain. The range refers to the other variable, g of x. What does g of x always have to be? Same as the other problem.
A positive or a neutral?
Yeah. G of x has to be greater than or equal to 0. In other words, x can be 1, making part inside the radical be 0. So g of x would be 0. So there is a way to make it 0, but there's no way to make it negative. Radicals of whatever are always positive.
Okay.
Or 0. Okay? Now, one of the ones that I was talking about, let's see, 3 and 4. So, we didn't quite do domains and ranges of f plus g. Let's go back and do that on number 1. Here's what f plus g is. Correct?
Yes.
Okay? What's the domain of that function? Where that's f plus g of x, f of x plus g of x. Well, what's the domain restriction on that function?
X either has to be 0 or greater than 0.
Can x be 0?
No, because then it wouldn't be a neutral number.
Why? In other words, the domain restriction, there was no domain restriction from that particle. But there was a domain restriction from that part of it.
Yes.
So there still is. In other words, adding the two together does not take away the domain restriction. So the domain restriction is still x minus 1 has to be greater than or equal to 0. That's always my starting spot.
Okay.
Okay? And let's look at the range of that. What is the range of f of x plus g of x? You know that this part of it always has to be positive.
Greater than or equal to 0?
Over 0, yeah. So the square root of x minus 1 has to be greater than or equal to 0. Not the x minus 1, the square root of it. And x is kind of limited by that. In other words, because x has to be greater than or equal to 1, this x here has to follow that restriction also. Whereas even though f of x all by itself, x has no restrictions on it, it could be negative. But as soon as I combine it with this other function and add it together, now my restrictions are whatever the greatest restriction is, I have to follow that. So x has to be greater than or equal to 1. So what's the range of this whole thing? If x has to be greater than or equal to 1?
Would technically the whole thing be, because if 1 is that, the rest of it has to be as well.
1 or greater, right? In other words, f plus g has to be greater than or equal to 1. Because the least it could be would be x is 1, right?
Yes.
Well, when I put in 1, I get 1. I get 1 plus 0. So the least it could be is 1. Could it be 2? Yeah.
Yeah.
I can figure out a value for x that the combination of these two things equals 2. Can it be a million? Yes. Can it be a billion? Yes. So the only restriction on the range is on the downside. It has to be at least greater than or equal to positive 1.
Okay.
And since this is always positive, Let's look at the second parts. Numbers 3 and 4 for f divided by g. Well, actually, we haven't done any of it yet. I assume on 3 that first f of x is equal to 2.
Correct.
And g of x is equal to x squared plus 1.
Yep. And for the next one, f of x is 1 and g of x is 1 plus square root x.
Take the first function only. What's the domain?
Would it be 2?
Yeah.
Darn.
The restrictions on x. We're saying it's a function of x. That's what the f of x notation means.
Yes.
But we're saying it's always 2. Well, that looks like a horizontal line at 2.
So negative infinity to infinity?
Yes. In other words, x can be anything it wants. It's not even in the function. The function value is 2, no matter what x is. If you look at this graph, x is minus 100, f of x is 2. F is plus 10, f of x is 2. So what's the range?
I believe it would be 2.
Yes, the range is 2. It was only 2, nothing but 2.
Okay.
Okay. Now, let's look at g of x, which is a parabola that doesn't go through the origin, it goes through point 1, because it's the regular-looking parabola that's shifted up by 1.
Okay, so that means it's 1.
Excuse me, what's the domain?
Negative infinity to infinity.
And what's the range?
1.
Can it be infinity?
Or yeah, 1 to infinity. 1 to infinity?
Yes. However, how do you state that?
I put a bracket in front of the 1 and a parentheses.
Okay, so you're using interval notation.
Yes.
Okay, that's the way to do it. Exactly. In other words, it depends on whether it can be 1 or not. If it can't be 1, then there will be a parenthesis next to 1. But in this case, it can be 1 if x is 0, and it can certainly go all the way up to infinity. Now, interesting that they didn't ask us for domain and range of the sum, but the division. So, what's the division? It's 2 f. G is x squared plus 1. So that's f divided by g. Now, what are the limitations on that function with regards to x?
So I have to keep it positive, correct?
No?
Or I'd say all real numbers.
It's a zero denominator, and you can't take the square roots of negative numbers. Well, we don't have any square roots here.
True.
If you have a denominator, is there any way that can be 0? Is there a value on x that makes that denominator 0?
No, because if you square any negative number, it becomes positive.
So that's always a positive number. So the lowest the denominator could ever be would be if x is 0, and then you would have 2
The
over
1.
1.
Yeah.
Okay? And if x gets really, really big, then you're going to have 2 over a really big number. In other words, you could have 2 over a billion, or 2 over infinity. So the domain was all real numbers, right?
Yes.
Of f divided by g, because there's no restrictions. X can be anything. It doesn't ever make a 0 denominator. So x can go from negative infinity to positive infinity, just like it could with both of the f, g, divided by G can be?
I believe as it is would be the smallest because there's nothing you can really simplify it with.
Let me ask a different question. Well, let me ask the other question, the one I meant to ask. What's the largest it can be?
Infinity?
I'm sorry, what?
Infinity?
Can it be 2?
Yes it can.
Can it be 3?
Yes it can.
How is it ever going to be 3?
Because I thought it would go straight up along Y.
In other words, you've always got 2 in the numerator.
Yes.
And the smallest the denominator can ever be is 1. Any value I put in for x makes the denominator bigger. So if I had 2 over 100, that's a smaller number, not a bigger number.
Correct.
So the biggest this answer can be f over g is 2 over 1. That's as large as it can be. So f over g has to be less than or equal to 2 over 1. And now let's talk about how big it. Now that was how big it can be. How small can it be? What if x is a billion? You have 2 over a billion squared plus 1. What kind of number is that? A tiny number or a big number?
If it's being divided, it would be a small number.
Yeah, it's a very tiny number. Now what if I make the billion be a trillion instead? Does the number get smaller or bigger?
It would be a lot smaller.
Right. So if I keep making this denominator as big as I can possibly make it, what happens to this whole thing? What does it approach?
It keeps going negative infinity.
Not negative.
Or infinity.
The negative signs you can never get.
Then
The
infinity.
denominator is always positive, the numerator is always positive. But it can get very close to 0.
Okay.
So f divided by g has to be greater than 0. And it can never actually be 0. In other words, I can make the denominator go up to a gazillion or a Google. And I can put as many zeros as I want in the denominator. The fact is as long as the numerator is a number and it's not 0, then this thing is never going to be 0, but it's going to get close to 0. As the denominator gets bigger and bigger and bigger, the result of the division gets closer and closer and closer to 0. But it never hits 0. There's no way to ever make it 0. So this thing is a greater than, not a greater than or equal. So there's your answer for range on number 3. What comes after the and? I'm not seeing that on my page.
1
Is
second.
there something else that they want besides f and g?
And g over f.
Okay. So the second and up here is f minus g?
Yes, it is.
Okay. Well, let's do the g over f first of all.
Or no, it's f times g, actually.
Ah, okay. What's f times g equal to?
2x squared plus 2.
What's domain? What's range?
I believe the domain would be negative infinity to infinity.
Correct. What's range?
Would it be 1 to infinity?
How do you make it be 1?
Because the plus 1 means that's the lowest it can be.
Not a plus 1 anymore. Multiply it by 2.
Or the plus 2, the plus 2. So it'd be 2 to infinity.
So the smallest I can make this total is 2.
Correct.
So that's your range.
Okay.
It's f times g has to be greater than or equal to 2.
Okay.
Okay?
Oh yeah, can we go on to the next page? That one's really difficult.
I realize that time is a consideration. You tell me the number to do.
Let's go on the next page I sent you, and number 11, that one looks pretty difficult.
Okay?
The latest one.
The latest?
Yeah, the latest one I sent you.
This one?
Yep.
Which one?
11.
On 11, we have f of x equals x minus 3. G of x equals square root of x. And h of x equals x cubed. And j of x equals 2. Express each of the following as a composite involving one or more of those functions. So how would I write 11a in terms of those functions?
I would need g of x, and I would need f of x.
So how would you write it? So is it f of g or is it g of f?
I believe it would be f of g.
Let's try both of them. Tell me what g of f is.
So that would be square root of x minus 3.
Right, is that what we're looking at?
Correct.
No, it isn't.
Actually, no, just square root of x.
Square root of x, and then minus 3 outside the radical.
Yeah, you don't want the whole thing inside of it, so it'd be f of g.
G of f gives us the whole thing inside.
Correct.
So what's f of g? We'll try it the other way.
So then f of g would be x.
And the way to answer that is, what is f of square root of x?
So then it would just be square root of x in the x place, and then minus 3.
That's what we're looking at. So what we have is f of g for a.
Okay.
Okay, and that's what we have to figure out, is how to write each of these functions as a composite. So the first one's f of g. Look at b. Y equals 2 times the square root of x.
So I'm going to need j of x, and I'm going to need g of x.
Okay? And give me the correct combination.
I believe it will be g of j, or j, wait.
I'm going to do both of them. So
Okay.
really, the way to answer the question is for you to do both.
Okay.
Let's figure out what g of j is. What is g of j?
2 times square root of x.
Is the square root of 2x, right?
Yes.
In other words, g of j is g of 2x. Which means I take the g function, and whenever I have x, I plug in 2x. So
Okay.
I get the square root of 2x, which is not what I'm looking at. We're looking at x. So now let's try the other combination, see if that works.
So j of g.
Eventually get this where you won't have to try both.
Okay.
Until you get it, this is a surefire way of doing it.
Okay.
What is j of g, which is the same as saying j of square root of x.
So that means I put the square root of x where the x is, so that would be 2 times the square root of x.
And that's what we're looking at. So that's what it is, j of g.
Okay. I actually like how you put that in there, how you put j and then the parentheses square root of x. I think that helps a lot.
That's very, very helpful. Always do that. Whenever you're looking at these j of things, in fact, even if I am looking at it like this, there's a lot of times they'll give it to you like this, with a double set of parentheses like that.
Uh-huh.
That means j of g of x. Well, we know what g of x is, so we'll substitute. So what that really means is j of square root of x. And now it becomes easier to handle. It's not as nearly as confusing.
Okay.
So that's a good thing to always do. Okay, so we got that one. Which two functions are going to be involved for C?
So for c, there's a 1/4.
C is a little tricky.
So I'm pretty sure I'm going to need the h actually, because that's the only one that has a coefficient, or not coefficient. It's going to the power of something.
Well, what does the 1/4 power mean?
That means it's I guess,
It's the fourth root.
yeah, the 4th root.
What's the square root mean? If I wanted to write the square root in terms of an exponent.
1/2, x to the 1/2.
Aha. What's the square root of the square root?
A 4th root.
Aha. That's what we're looking at.
Okay, so
What is it a composite of? In other words, they didn't tell you you had to use two different functions. You can have g of x. In other words, this is what we are looking at, right there. Why? Because we're looking at g of the square root of x. And if I plug that into the g of x function, that gives me the square root of the square root of x. And that means the same thing as x to the 1/2 taken to the 1/2 power.
which makes it,
Once you get x to the 1/4 power, and that's what we're looking at. So it's g of x.
okay, that's weird.
It is a little, that's why I say it's a little tricky, because you're not expecting that you can use just one function. But you can. There's no other way to do it with those four functions other than that way. Now, I don't blame you for thinking h of x had to be involved. No, but h of x is something cubed. And you have a hard time getting from something cubed to x to the 1/4.
Mm-hmm.
So the secret really is to know that this is x to the 1/2. And, you know, once you get into calculus, it's always better to write functions with exponents instead of radical signs. They have this thing in calculus called the power rule that you need the exponent to even begin. And so the standard practice when you're taking calculus is to not write with radical sign. You don't know what to do with a radical sign, but you certainly know what to do with an exponent that's to the 1/2. All right, how about D?
Okay. So for D, y equals 4x. So it'd be j of 2.
How about j of 2x?
Or j of 2x, because that's to get
Then
multiplied.
would it have to be j of 2x?
Say again?
Which means what is the composite going to be? What would j of 2x be?
So then that'll be 2 times 2.
Well,
Oh.
I'm going to plug in 2x for x, so I end up with 4x, right?
Yes.
That is what we have. Now let's backtrack, and what's j of 2x equal to? Is that not equal to j of x?
Yeah, that is true, because it's 2x. Yeah, since they're both
What
2x.
j of x.
Okay.
So it's j of j.
Okay.
Okay, so another one where we only had to use one of the functions. E is pretty easy. What's E? Which two functions are we going to use? In fact, we might have to use 3 functions on E. Yeah.
Yeah, f, h, and g.
Notice that E has a square root, in other words, function g. It also has the x minus 3, which is function f, and it has a function cubed, which is function h. So if I were to try putting all 3 of those as a composite function, what would I get? So here's the 3 functions are this one, and this one. Put them together properly. In other words, we're going to have something that looks like f of g of h, or some combination of those 3.
Okay, so
the outside.
So I know g of f.
That's g of x, right?
Yes.
So I'm going to start with g of, and then what's next?
I believe it would be f because you want the x minus 3 all square rooted.
We're taking the cube root of it. Well, we're taking this to the 3rd power. That's h. So how about f of h of f? I'm sorry, g of h of f. What does that mean? Let's back it. This is a strange one.
Yeah, it is.
That's what I think the answer is. Now, let's see if that's the answer. Well, f of x is x minus 3, so we're taking g of h of x minus 3, you with me?
Mm-hmm.
What's h of x minus 3?
That'd be x minus 3 to the 3rd power.
So now we're taking g of x minus 3 to the 3rd power. And what is that?
Then that'll make it square root of x minus 3 to the 3rd.
Exactly. And that's what we're looking at. So we found 3 functions that fit the 3 things happening to that composite. And there are 3 things happening. We just have to figure out the order to put them in, and basically work from the outside in. In other words, the very first thing going on is the square root. That's the g function. The next thing going on is this thing is being cubed. That's the h function. And the third thing going on is that we're looking at x minus 3. That's the f function. So you kind of work it outside in.
Okay.
Let's do that f also, because that's another one. How many functions are involved in f?
So 2x, so that's j minus 6. So that means we have to have f as well. And then the cubed is h. So I believe 3 functions. Since we don't need g. Since there isn't a square root.
Correct. We don't need g. We're definitely going to need h. Not sure we need anything more than f.
We might need j.
Can this be an answer? In other words, I'm not 100% sure about this. Let me think about this for a second. In other words, what if we did 2f? What if we did h of 2f of x? Not sure that's an allowable answer, but notice that that would be correct, correct? What's 2 times f of x?
2 times f of x. That would be 2x minus 6.
Correct. Now, if I take h of 2x minus 6, I get the answer we're looking at. Right?
Yes.
Okay. So, I think that that is an allowable answer. Let's see. Express each as a composite involving one or more of those functions. Can I use a constant? That's the question. Let me think as to whether there's another way to do this. Using 3 functions, perhaps. I don't want to waste all of our time trying to figure out these super hard ones like this. But I don't see. Hold on a minute. No, if I said f of j, well, that would be f of 2x, and that would be 2x minus 3, not 2x minus 6. So you see my problem?
Mm-hmm. Yeah, that's weird.
Well, I think that your answer is going to be what I put down there, which is h of 2 f of x. That should be allowed. They didn't say we couldn't use numbers.
True.
At least I don't think they intended that. Let's work on 13 a little bit. In other words, 12 is going to be basically the same as 11. And 11 was 6 tough problems. It wasn't just one problem. Okay? So we don't really have time to do 6 more problems, and they're the same nature. Notice that 12c I could get by taking h of x, right?
Yep.
I took h of x, then I got x cubed, which is x to the 9. So 12 are similar. Let's make sure you can do 13, some of these. What's f of g? I think you're pretty good on these, but let's make sure. Let's have you do A. What is f of g of x? And again, do it the way I did it. In other words, that means this. What's the next thing I should write?
The square root of x. Or no, x minus 7.
Now, what is f of x minus 7?
Square root of x minus 7.
Answer. For B, what is f of g?
3x plus 2.
Parentheses or not?
Yes, parentheses. So 3 parentheses x plus 2.
Well, it actually ends up being 3x plus 6, right?
Yeah, 3x plus 6. Correct.
And you put it simplify. In other words, you don't want to give the answer as this, which is what you did. But because I can simplify that, I can turn that into 3x plus 6, I should do it.
Okay.
I guess. Either one of them probably is correct. I don't think you'd maybe even lose points if you put that answer down there. What you would lose points on is if you put it this way, 3x plus 2 without the parentheses. That's not correct.
Okay.
Okay? All right. So now let's see if we can go backwards for C. That's what's tricky about D. Is what must g of x be such that f of g is the square root of x squared minus 5 for C? The only thing I can really suggest here is experimenting.
I believe it would have to be a squared number.
So let's figure out if that's true. If g of x is x squared, and f of x is x, the square root of x minus 5, then f of g of x is the same as f of x squared, and that is
x squared minus 5.
X squared minus 5. So that is the correct way to do it. And you have to do that on all of these. I guess. So there may be some easy way to do this, but I really don't know of it. The best way is to try to figure out if you think you know the answer and then test it. And if your test does not produce this, then it's not the correct answer, and you need to go back and fiddle with it. The hardest ones here are going to be where you have to fill in either g of x or f of x.
Okay.
Okay. Let's see. We got another few minutes. I don't think you have any problem figuring out f of g.
What about e? E looks weird.
E. Did you say e?
Yes.
Okay. So f of x is that. F of g of x is that. Wow, what would e be? How about e is maybe 1 plus 1 over x. Oh, hold on. Oh, that's not what I meant. I meant yeah, it is what I meant. In other words, what if that was g of x? Now, what is f of 1 plus 1 over x going to be? In other words, we know what f of x is. It's 1 plus 1 over x. Ah, that's not right then. But we're close. How do we get x to be the composite? Wow.
So do we have to multiply reciprocal, possibly?
Add those two fractions together. That's maybe the way to solve that. If I add 1 plus 1 over x, I get x is the common denominator, and I get x plus 1 right there. So that's my fog. No, excuse me, that's f of x. Okay, so let's be clear what we're doing here. 1 over x. And that might help. Now, for this to turn into x, you have to multiply it by x and then subtract 1. In other words, if I took f of x, multiplied it by the quantity x, and then subtracted 1 from it, I would end up with x.
Okay.
Okay, f of x is this. If I multiply this by x, gets rid of the x at the bottom. If I subtract 1 from it, I'm left x. So that produces this. So what must g of x be? About g of x is x squared minus 1. Now, what is f of x squared minus 1? If f of x is this, which it is, and if I plug in x squared minus 1 for top and bottom, I get x squared minus 1 plus 1 all over x squared. That doesn't leave you with x. So that's not right.
It'll be okay.
I'd have to work on that for a little bit and play around with some things.
Okay.
And you basically have to come up with a g of x such that fog is equal to x. And as you can see, it's not that easy to do. I played around with a couple of them, and we don't really have time for me to just guess functions and go through all of them.
True.
But that's kind of what you're faced with here.
Okay.
If you have to figure out the third column, you're in like Flint, I believe, right?
Yes.
Just always do it the way I did it. In other words, fog of x means f of g of x. And whatever g of x is, plug it in, and then take f of whatever it's plugged in. So those are not difficult. The ones that are difficult are C, E, and probably F. Although I'm thinking F is probably x squared, maybe?
Mm-hmm.
Yeah, no? Because if you squared 1 over x, you'd get 1 over x squared.
True.
So F must be 1 over x. Well, let's do that real quick before I run.
Okay.
In F, if I take the f function, in other words, the g of x, I'm told is 1 over x. And I'm saying, let's make the f of x 1 over x. Well, now what's f of 1 over x?
1 over 1 over x.
1 over 1 over x, which is equal to x. And that's what we're looking at. So in f, it really is the same function. F is the same as g. It's 1 over x.
Okay.
And I can see it here, but I can't see a regular pattern as to how to figure it out when you're going backwards. There might be one, but I haven't figured it out yet.
Okay. Well, thank you.
All right, Jared. You have a good night. I'll talk to you next time.
Thank you, too. Bye.